So we did push back. We did push back the quiz till Friday. So tomorrow we're gonna have a little review time and some extra time to finish this quadrilaterals packet. But you got to be working today. These other class periods, they got people sitting like they got nothing to do. And I look at their grades, and that ain't true. So everyone should be working on that quadrilaterals packet today. And the warm-up is supposed to set you up to be successful on it. I'm trying to show you some examples, so please follow along. There is too much going on here to fit all on your warm-up sheet. I get that, so at least maybe you can fit in the first two. And I'll just leave it on the board for you to take a peek at when you're doing your assignments, okay? So don't forget about angles and polygons. This thing's going in the grade book soon, okay? So the first one up here, it tells us that this shape is a what? Parallelogram. Y'all see that? Now, on our notes, we definitely went over what a parallelogram is, blah, blah, blah. But let me tell you, if you look right here, on the back sheet of your notes, okay, you kind of got all the properties you need in one spot. So, bless you. Let's talk about what is a parallelogram. So the very first thing it says next to parallelogram, right, is it's got opposite sides that are parallel. That's why it's called a parallelogram. But the second thing it says is opposite sides are congruent. What does congruent mean? Same size, same shape. You can literally put tick marks on it. So everybody do that. You see the 2x plus 5 and the 4x minus 5? Okay, those sides have to be congruent, which means that their measurements are equal. Okay, so when you know it's a parallelogram and you see opposite sides, you can literally set them equal to each other and solve. Okay, that's what I'm going to do. Here we go. 2x plus 5 has to equal 4x minus 5. Okay. You gotta remember and be able to solve these types of equations, okay? X is on both sides of the equation. So what do we do when X is on both sides? Do I combine them or get rid of one? Okay. When it's on both sides of the equation, we get rid of the smaller x, which is 2x. To get rid of a positive term, what do? Subtract, yeah, so minus 2x on both sides. Bring down 5 equals 4 minus 2 is 2, and bring down that minus 5, okay? So again, x is on both sides. I get rid of the smaller x. Now, it's a two-step equation on the right side. What do I need to get rid of first over here? The loner minus 5. The opposite is 2. Add 5 to both sides, yes. So 5 plus 5 is 10. And what's my last step to get rid of that 2? Dividing by 2, okay? To get rid of a coefficient, we divide. Divided by 2. So x is going to equal 10 divided by 2 is 5, okay? I'm telling you, on your assignments from yesterday that you got, you have a good amount of problems like this. Opposite sides, if they're equal or congruent, you set them equal and solve. Is that doable? Because the way some people are acting today, it's like impossible to do because they're just refusing to work. But not y'all. Y'all are going to be my all-star class. All right, here we go. What about y? Do you see these angles? They're inside, and they are opposite. They're across from each other. So once again, what do I know about the opposite angles in a parallelogram? It says opposite angles are congruent. What did we just do with congruent things? We set them equal. Okay? So if you see opposite angles on a parallelogram, you know this equals this. So you're gonna set them up the same way. So 10y has to equal 2y plus 16. Could you solve that one like the last one? You wanna write this down? On Wednesday. So there's a y on both sides. So once again, get rid of the smaller y, which is 2. So minus 2y, minus 2y. I get 8y equals 16. And then to get rid of that coefficient 8, we divide by 8. So y equals 16 divided by 8 is 2. Okay, so that was the first figure. The second figure off to the right here is also a parallelogram. But notice where the angles are. These two angles are not opposite, like through the middle. Okay, they are actually like next to each other. You call those either adjacent or actually, better word is consecutive. That's what you're going to see on here. Okay, but these angles are consecutive. The 3z, that is an obtuse angle. That's big. The 7z minus 40 is an acute angle. It's less than 90. These don't match. They're not equal. You don't just set everything equal when you're doing these. You got to think about it. So these, since they are consecutive, I'm looking at my notes, it says consecutive angles are supplementary. What does supplementary mean? Supplementary is when two angles add up to what? 180. All right. So instead of setting these two equal, we're going to add them equal to 180. Because they're not opposite, they're not congruent, they're consecutive, they're supplementary. So let me show you how that looks. And I'm going to label it real quick. This is one arc. This will be two arcs. They're not the same. So we're going to add them up equal to 180. So 3z plus 7z minus 40. And then I put the equals after it, equals 180. That's what it means to be supplementary. Cool. Okay, now this time my z's are not on different sides of the equation. They're on the same side. So do I add them or do I combine them or get rid of one? Combine like terms because they're on the same side. So what is 3z plus 7z? 10z. Bring down minus 40 equals 180. And then you should be able to get rid of the loner, add 40 to both sides. That gives me 220. And then divide by 10. 220 divided by 10 is 22. So z should be 22. Now that might be all the space you have on there. Make sure you've written down how we got these, right? But I still want to show you a few more examples. So stay with me, like looking up here. Hey. Yeah, you. No. Yeah, thank you. Now, I want to show you 3 more examples. Even if you don't have room to write it, I want you to see what I'm doing here, okay? What if you have a rectangle? What if you have a mid-segment? What if you have a kite? Okay, so here's some more examples on how you're going to use your notes. Now, look at this. This says it's a rectangle. What do we know about these angles of a rectangle? What do you think you know already about the angles of a rectangle? The diagonals are congruent also, but specifically the angles, it just says 4 right angles. That's what makes a rectangle a rectangle. All the angles are 90. That's it. Okay? So I can label that like this. 90, 90, 90, 90. Okay, those are kind of ugly, sorry. It is what it is. So these are all 90. So guess what I set 3p equal to? 90, yes. All right, so 3p equals 90. What's my only step that I need to do to solve for p? How do I get rid of that 3 in front of p? Divide, okay? Divide by 3. What is 90 divided by 3? 30, okay? So when you have a rectangle, when you know what the angle equals to, you set whatever's there equal to that number and solve, okay? Now, this one in the middle here, this is a trapezoid. Let me remind you of, this was the last thing we did on the notes yesterday, okay? It's this trapezoid mid-segment theorem. Okay, so it looks like this. It's at the bottom of this page. All it tells you to do to find a mid-segment, you have to add the bases and divide by 2. You're basically averaging these two numbers to get the mid-segment. So here's what it looks like. Ready? The mid-segment, which is M, equals base plus base divided by 2. The outside plus the outside divided by 2 gives you that middle one. So could you plug that in your calculator and do the math for that? So check it out. I already did it. 6 plus 16 divided by 2 is 11. 11 is halfway between 6 and 16, for sure. Okay? Can you find a mid-segment given 2 bases? Okay? Now it gets a little tricky when you're missing a base and you know the mid-segment, but I'll let you all figure that one out. Last one. We also did examples of kites. The one thing you got to know about a kite, again, it's on here in the back. There's only one pair of opposite congruent angles. Here's what I mean. Look. Everyone look. When you have a kite that's upright, the left angle and the right angle, these ones are the same. These match. But the top and the bottom, they don't match. So here's how I show that with my labeling here. This angle has to equal this angle, for sure, on a kite. But the top and the bottom do not match. So if this is 102, what is n going to be? 102, right? These angles match. So 102, n is 102. But r is not 72. Is everyone seeing me looking over here? See this? Okay. R is not 72 because that's what makes it a kite. Those opposites are not the same. So do we have any ideas? How would I figure out angle R if I know these 3 angles? What is the sum? What do they add up to inside of a 4-sided figure? It is 360. Now, if you don't know what they add up to, do you remember this sum of the interior angle formula? Like if you plug in 4 minus 2 times 180, you get 360. Okay? So, just as an aside, you can use this over here. 4 minus 2 times 180 gives you 360. And you know 360 is what they add up to inside of a kite, any type of 4-sided figure. So I could take the 3 angles I know, add them up, 102, 102, and 72. I would get 276. Subtract that from 360, and I get 84 degrees. Recap. Kite has only one pair that are equal, so you know what this is 102. Take the 3 you know, add them up, subtract from the sum, 360, that'll give you the missing one. So when you get to the kite problem, there's an example. I'm going to leave this on the board. Okay, it will be uploaded eventually, but for sure it's going to stay on the board during class. Does everyone have this assignment? Should have got it yesterday, but it's right here. You missed it. It says quadrilateral properties practice. It's right here. You get it. All right. I'm going to let y'all work on that. Tomorrow you'll have a little more time, but you've got to review tomorrow because we have a quiz on Friday, for sure. Does everyone understand the trajectory of the week? All right. Let's do it.